Assalamualaikum and good day. My name is Najmi bin Muhammad Seth. My metric number is M122320003, and this is a presentation for assignment 1 for MENC 5223 Digital VLSI Design. Okay, let's go for the introduction. Okay, the truth table provided is the question from the assignment sheet, and from this truth table, I decided to use Mealy FSM. And what is MEAL FSM? It's a finite state machine which output values are determined both by its present state and the input. Shown in the diagram below is that both have Mohd and Mealy machine has the same component, except for the Mealy machine, the output combination logic is fed by the inputs shown by the arrow. Okay, let's go to the methodology. Okay, from the truth table, we can see there are, based on the bits on the present state, we can have 4 states. Okay, S0, S1, S2, and S3. Let's look one by one. Okay, for S0, regards there's with regards to disregard to all inputs, the next state will always be S1 and no output. And for S1 is that for 0, 0, and 0, 1 input will go to S3. The next state is S3 and no output. For 1, 1 and 1, 0, the next state is S2 with no output. Okay, next is S3, even though it's on the third position, the 1, 1 is definitely S3. Okay, for 0, 0 and 1, 0, the next state the state will remain on S3, but for 0, 1 and 1, 1, the next state is S0 and the output is 1 for all input. Okay, for S2, here is that 0, 0, 1, 0, they will be look back at S2, which is or remain in S2, but output is OE is 1. But for 0, 1 and 1, it will return back to S0 with output OE is 1. Okay. This is the algorithmic state diagram, which is pretty much this is a flow chart of those state diagram that should look side by side. Okay, and F0, then you need to make decision, but for S0, all inputs will lead to S1. Then at S1, there will start branching from to 0, 0, 0, 1 to S3 and 1, 0, 1, 1 to S2. Okay, on S2, same as state diagram, 0, 0 and 1, 0 will look back, will remain at S2, but with output OE is 1, but 0, 1 and 1, 1 will return to S1 and output OE is 1, but for S3, similar pattern to S2, 0, 0, 1, input 0, 0, 1, 0 will look back to S3 with output WE1 and 0, 1, 1, 0, 1 and 1, 1 input will return to S0 and output WE is 1. Okay, here's a chem map for present state Y1, Y2, OE, output OE, and output WE. Okay, for Y1 chem map, as you can see, there are two groups which result in this equation, Y1 bar and Y2, or Y1 and RDY bar. And for Y2, there are three groups which result in this equation, Y1, Y2 bar, and Y1 and RW bar, or with Y1, Y2, RDY bar. For the output OE, there is only one group which result in this equation, Y1 dot Y2 bar. And for the last output WE, still only one group will result in this equation, which is much simpler, Y1 and with Y2. This Boolean equation will result in this circuit. As you can see, the circuit can be validated by using this Boolean equation. Okay, next we go to result discussion, which on Vivado software we show the codes and the timing diagram result. Okay, this is the Vivado software. Let's look at the codes. First, we instantiate all the output and input. For the input clock reset and the input RW, RDY, just as truth table. And then for the output is OE, WE, and for the PSNS. And then we use state encoding parameter 120 for it because it's 4 states, so it's used to bit S0, S1, S2, and S3. And then for we use state register, its initial state, post edge clock and post edge reset. It means if the reset button is pressed, all present state will return to state 0. If not, we go to next state. Can we go to the next state logic? Okay, initially NSSPS output is 0. Let's look at S0 here. Like the truth table or the state diagram, all input of the on the S during S0 will lead to next state of S1. But for S1 we start getting there's a new direction. For 00 and 01, 01 will go to S3, and 10 and 11 S2, just as the state diagram. And for S2, 00 and 10 will lead to S2. Next state is S2, and 01 and 11 will go to S0 for S3. But for the S2, the output will start to return to 1. The OE is 1, and for S3, the WE is 1, 00 and 10 will remain on S3, and 01 and 11 will go to S0. Default begin just to close it off. Okay, let's go to its test bench, the same as previous. Okay, set all input to 0, and then for its clock, I use this random numbers to see all possible output on the timing diagram. Okay, let's see the timing diagram. Okay, it's timing diagram. For the input is the purple one, the output is for OE is the orange, and WE is for the yellow. Okay, let's look at this first. First, initially if X don't care. Okay, and then the first clock arise. We go to present state 0. Okay, just like the state diagram, all input will result in next state of 1. And then when you go to next state 1, you can see here 1 0, the input 0 0 will go to state 3, just as the state diagram stated, and so on so forth. And then when you go to state 3, the input of WE will go to 1. To 1 as he show here. And then we go to forward. We'll repeat the same pattern because of the input and the clock number. Okay, let's go here for the OE, output OE. You can see here the output OE only 1 when the present state is 2, which is shown here, number 2. Okay, and as usual, the input, if it's on 2, if the present state is 2, the input is 1 0, will go remain at 2. Let's check 1 0, 1 0, 1 0. Yes, remain at S2. And this is the whole timing diagram for this truth table. And then we go to conclusion. Okay, let's go to conclusion. The conclusion is that creating the algorithmic state machine, flowchart and state diagram help translate a state table into a visual and logical representation of the digital system, reinforcing the ability to perform simulation and design tasks using Verilog and bridging theoretical knowledge with practical application in electronic circuit design. Next, the code that I created is made easier to read and maintain by using parameter for state encoding and clearly separating the state register combination logic block. Because of this methodical approach, future adjustment and debugging will be easier, resulting in a robust and effective design for real world users. These are some reference I use mostly on lectures note and lecture tutorial and some internet site which help me for the multiple output and input. That's all from me. Thank you.